Nothing more complicated than that. It's just that we usually want a function to be written in terms of x, so we need this fourth step of switch x to y. Excuse me, switch y to x, right? It's really not a big deal, but it's something I need to talk about at least a little bit. So, hey, let's do that. Let's see here. So, I mean, there's one example already, example 9. Let's look at example 10. Suppose we have f of x equals to, say, 3x minus 1 over 2x plus 7. All right? Find f inverse of x. And I also want us to look at the domain and the range of the function and its inverse while we're at it. Can you guys tell me the range of that function? What's the range of the function I just wrote down in example 10? Can you tell me? I can tell you the domain, right? That one we can do for free. The domain here is minus infinity to something, unioned with something. We have to exclude one point. What point do we have to exclude? We have to exclude where the denominator is 0, right? Where's the denominator 0? The denominator 0, when you put in, what makes 2x plus 7 equal to 0? Right, so we need to exclude minus 7/2. That's the domain for the function, okay? What's the range? You'd have to think about it, right? So I'm going to leave a spot to put that in later once we find it. All right, we'll fill in that blank. Let's find the formula. Let's find the formula. So step number 1. Y equals to 3x minus 1 over 2x plus 7. All right? What's our next move? Our next move is to solve for x. How do you solve for x? What do you do? I'm going to start by multiplying by the denominator, right? So that's going to give me 2x plus 7 times y equals to 3x minus 1. All right, then what? I suppose we could multiply out the left-hand side, right? This would give us what? 2xy plus 7y equals to 3x minus 1. Well, that seems better. We want to isolate x, right? So move everything with x on one side and everything without x on the other. So we've got 2xy minus 3x is equal to minus 1 minus 7y. All right? I can factor x out, right? I can factor x out, so I should factor x out. X times 2y minus 3 is equal to minus 1 minus 7. Don't lose track. We're trying to solve for x, right? So we take steps towards that goal. Now divide, and we got it, right? X equals 2. So here's that stuff in y I was talking about. Minus 1 minus 7y divided by 2y minus 3. This is the quote-unquote stuff in y for this problem. So that's step 2. Step 3 is just to say, oh, hey, well that's exactly f inverse of y. There's the inverse function of y. If I just say to find a formula for the inverse, you can justifiably write that down, put a box around it, you're done. But if we want to find f inverse of x, we've got one more step, right? What's the one more step? So step 4, just write down f inverse of x equals 2. How's it go? Minus 1 minus 7x divided by 2x minus 3. Some of you guys talk to a tutor, right? if you're talking to a tutor, be careful to show them your notes and show them how I did this, because if they start by flipping x and y, like you can't flip x and y twice. You do it once in this process, but not twice. So if you do it at the start, then you should do it at the start and not do it later, right? Just, whenever if you're working with a tutor, make sure they have seen this 4-step process, yeah? So that they're on board with how we're doing things in here, But there it is. Hey, what's the domain of f inverse? Can you tell me that? See, because the range of f, right, is equal to the domain of the inverse function, right? What is the domain of the inverse function, though? See, that you can tell from this formula, right? What's the domain of f inverse? It's x such that what? 2x minus 3 is not equal to 0, right? Which is in other words, what? It's minus infinity. So we have to have what? X not equal to 3 halves, right? So we have to exclude 3 halves from the domain of the inverse function. And so you see this? We just calculated the range of the function without actually graphing the thing, didn't we? So this is a trick. You can figure out the range of a function by looking at the domain of the inverse function. And if you do this, then you don't even have to graph it to see the range, which is kind of a sneaky trick. Of course, it might be instructive here to graph the function and its inverse, right? In this example, because if we did that, then we would gain sort of further insight to that table comment right there, right? Any questions? Well, that's pretty much all I have to say about inverse functions in here, all right? So the next topic we're moving on to is exponentials and graphs, all right? So I'll tell you this much today. Oh, actually right there. See this right here? My example 7? Example 7 is already an example of an exponential function. So like, if we go back over here. So this red line here, the formula for that very well could be, y equals 2 to the x. So just to give you the terminology here, f of x equals x squared is a power function. F of x equals 2 to the x is an exponential function. It's kind of the same kind of formula, but they're very different in their nature. In terms of here, the x, the variable is in the exponent, right? Whereas the power function, the variable is in the base. So an exponential function has a fixed base. Here the base is 2. Like more generically, an exponential function looks like this. F of x equals a to the x. So here the base is a, and that's fixed for an exponential function. Now, look, y equals 2 to the x is a 1-to-1 function, right? Which means it's invertible. The inverse of the 2 to the x function, all right, just to give you a sort of a window into the next lecture, this guy is actually y equals log base 2 of x. Log base 2 of x is the inverse function of 2 to the x. And so it's characterized by the following two properties. 2 to the log base 2 of y is equal to y. And log base 2 of 2 to the x is equal to x. And this is for y positive, and this is for x real. So the log base 2 and the 2 to the x, exponential base 2, these are inverse functions of one another. And anyway, we will study the properties of these things and how to solve equations and all kinds of things, what their graphs look like, blah, 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 blah. Although pretty much here's the graph already, right here. This is the graph of the logarithm. It's just the exponential like that, the exponential. Anyway, I'm going to get out the computer and start the next climb and look at some pictures with you on the Desmos most likely. But I think that's it for today. So I'll give you back your test now.